Today, we're going to be discussing the coordinate plane, something that everyone should know a lot about, but let's review just in case. A couple of key features of the coordinate plane everyone should know about is one, we've got a line that goes from left to right. It's called our x-axis. We've also got a great line that goes up and down. It's called our y-axis. We have 4 quadrants in every coordinate plane. Quadrant 1, 2, 3, and guess what? 4! The first quadrant is the upper right-hand quadrant. In that quadrant, you have a positive x value and a positive y value. In quadrant 2, you always have a negative x value and a positive y value. Quadrant 3 has a negative x and negative y, and quadrant 4 has a positive x and a negative y. Moving forward, you can also see that we have something in the center there, that little red dot. That is our origin. This point is where x is equal to 0 and y is also equal to 0. You'll see several questions where they ask you about the origin, so it's important to know where it's located. Let's talk about some problems you might see that revolve around the coordinate plane. Let's take a look at this first question here. Rectangle ABCD has vertices A, -3, 6, B, 4, 6, C, 4, 1, and D, A, B. What are the coordinates of point D? Students often try to do this question just by visualizing what this might look like. Certainly easy to picture a rectangle in our heads, but it's not so easy to figure out what one coordinate might be based on the others if we're just doing it based on visualization. So let's actually draw this out so that we can see perfectly what it looks like and get a correct answer. If we draw this, it'll look something like this. We can see that vertex A is at -3, 6, vertex B is at 4, 6, so C is at 4, 1, and again we're looking for vertex D, which is at points A, B. The way that we figure out exactly what the coordinates of point D are by using the other coordinates that we see in front of us. So we see that point D has the same x-coordinate as point A. It's the same distance left from the y-axis as point A is. So it has to have the same x-coordinate. So that's going to be -3 for the x value. We also see that it's the same up and down value as coordinate C, which is 4, 1. So it's got to have the same y value as coordinate C, which is +1. So the overall coordinates for point D will end up being -3, 1. Let's take a look at another question. Rectangle ABCD has vertices A, -3, 6, B, 4, 6, C, 4, 1, and D, A, B. What is the perimeter of ABCD? We'll notice that this is pretty much the same question as the last one we just saw, except it's asking us for the perimeter of rectangle ABCD. Let's draw that out again and see if we can figure this out. So we knew what this looked like from the question before. Now we need to figure out how long it is around the shape. If you guys remember from your lessons in 7th, 8th, 9th grade, perimeter is just the distance around any figure. So we can easily figure this out by calculating the distances between points, which is easy when you're looking at x-coordinates and y-coordinates. Looking at line segment CD, we'll notice that the distance from C to D is going to be the distance between those y-coordinates, which is just the difference between 6 and 1, which is 5. And the distance between segment AB is just going to be the distance between the x-coordinate of A, which is -3, and the x-coordinate of B, which is +4, which is a distance of 7. So now finding the perimeter of rectangle ABCD is really easy. It's just going to be the sum of segment AB, segment DC, segment BC, and segment AD. Since we know that segment AB is 7, segment DC also has to be 7. It's a rectangle. And since we know that segment BC is 5, segment AD also has to be 5. Again, it's a rectangle. So we add these all up and we get a really easy perimeter of 24. We can also use coordinate planes to figure out distance. Thinking about the question we did before, we were actually using distance to figure out the distance between the x's for that rectangle and the distance also between the y's. But what happens when we don't have something that's so clear-cut, straightforward as a vertical distance or a horizontal distance? Let's take a look at this question. What is the distance in coordinate units between point P, 2, 2, and Q, 6, 5? What did I say just a couple minutes ago, if you think back? I said, anytime you have a question like this, it always helps to draw it out. So let's draw this out. If we draw it out, we see that it looks just like this. And that's not a vertical line or a horizontal line, it's a slanted line, it's diagonal. So we can't just calculate the distance between x's or y's like we did before, we have to do something else. In this case, the best way to approach a question like this is to form a triangle, a right triangle that's going to look like this. We can easily figure out from this drawing what the coordinates of point R are. Coordinates of point R is going to have the same x coordinate as point Q and the same y coordinate as point P, which is going to give you a coordinate for point R of 6, 2. Knowing that, thinking about what we can do now to figure out the distance between P and Q, we have a right triangle in front of us, right? We'll get to why that's important in a minute. But let's figure out these distances between Q and R and P and R. The distance between Q and R is 3. It's going to be the distance between the y's of Q and R, just like we did before. And the distance of 4 for PR is going to be the distance of the x's between P and R, just like we did before. How do we now figure out what PQ is? Well, since we have a right triangle, you should remember our old friend, the Pythagorean theorem. We can use that here. And just use the simple formula a squared plus b squared equals c squared. We know that a is 4, and we know that b is 3, so we can plug those values into the equation, and we have 4 squared plus 3 squared equals c squared. And solving that out, we get that 25 equals c squared, which means that c is going to equal to 5 when you take the square root of both sides. Very, very simple. We also can use the distance formula when calculating distance between any 2 points. So taking that same problem we just did a moment ago, instead of using a triangle, we could have used a very simple formula that looks like this. Distance always equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Basically the difference of the x's squared plus the difference of the y squared, and taking the square root of that is going to give you the distance between any 2 points. Shh, here's a little secret. The distance formula is the same thing as the Pythagorean theorem, but just written in a different way. So for this question, we can plug those values into x and y, and we'll get the same thing. We'll get that d eventually equals radical 25, which is 5. Midpoints are also important. What is a midpoint? A midpoint is as simple as it sounds. It's the middle of any line segment, just the middle point between any 2 endpoints. So if we wanted to figure out the midpoint for a question like this, it'd be really easy. Let's read this. It says, what is a midpoint of 2, 2 and 6, 5? So again, we're looking for midpoint, and we can use a simple formula that'll help us figure this out. I gave you guys a hint earlier when I said they tell us exactly how to do it just by its name, midpoint. When we think about midpoint, we think about the middle. And middle can always be kind of equated to thinking about average. So midpoint is basically just the average of your x values and the average of your y values. So thinking about this as an equation, we can write it as x2 plus x1 divided by 2, comma y2 plus y1 divided by 2. And using that equation with these points that we have here, we get 2 plus 6 divided by 2, comma 2 plus 5 divided by 2. That's the average of the x's and the average of the y's. That will give us the midpoint of this line segment, which is going to be 4, 3.5.